All right, so we're going to look at linear graphs. What we want to do is complete our table of values and plot the points on the graph after we complete the table of values. So I have here a question. We want to complete the table and draw a graph for y is equal to 2x plus 1 for x is equal to minus 2 to 2. Now, sometimes this could be written differently. You could see x is less than or equal to 2, greater than or equal to minus 2. So it's within these values, inclusive of the negative 2 and 2 as well. Now, what I would usually instruct my students to do is to take this equation. We have this equation here, y is equal to 2x plus 1. And I want to break it up into parts. So I have the 2x and I have the plus 1. Now, what you're doing is you're actually changing values for x. You're replacing this x with each one of these values. This, then this one, then this one, then this one, this one. What the table of values allow us to do is to work out in a tabular format the corresponding value for y when we change values or x assume these values here, negative 2, negative 1, 0, 1, and 2. So we want to know what is the corresponding value for y, right? We're going to end up with pairs of values or pairs of coordinates. When x is minus 2, what about when x is minus 1? What about when x is 0? What about when x is 1? And what about when x is 2? So let us break this up into two parts. I'm going to write it vertically, so to speak. So 2x and plus 1. Now, regardless of the value of x, plus 1 will always be plus 1 throughout, right? What I will do here is I'll be multiplying 2 by each one of these values that x could assume. So 2 by negative 2, right? If we do 2 by negative 2, what will we get? We'll get minus 4. What about when we say 2 by negative 1? We will get negative 2. What about when we say 2 by 0? We will get 0. Anything by 0 is 0. 2 by 1 will give us 2, and 2 by 2 will give us 4. So now we could work these things out, right? We could work out what 2x plus 1 is, and that's actually going to give us our y. So I'll write here 2x plus 1. So 2x is minus 4 plus 1. That's going to give me, let me just draw a line underneath this. That's going to give me negative 3. And then we have minus 2 plus 1 will give me minus 1. 0 plus 1 will give me 1. 2 plus 1 will give me 3. And 4 plus 1 will give me 5. So now we have the corresponding y value for each of these x values. Right? These are our pairs of coordinates that we'll be plotting on the graph. So we have, I'm going to write them on the side here. We have x and y values. First point we have is minus 2, minus 3. Then we have minus 1, minus 1. Minus 1, minus 1. Then we have 0 and 1. 0, 1. Then I have 1 and 3. 1, 3. And then we have 2 and 5. 2, 5. Right? So the first number is our x value. Let's make this a little smaller. And the bottom number is our y value. So when we talk about our x coordinate, we're talking about horizontal movement, either from the left, from the center going to the left or to the right. So my x value is how much spaces are going to move to the right or to the left. So if I have a minus 2, minus is to the negative side. So I'm going 2 units to my left. And then we have a negative 3 here, right? So we're going 3 units down. 1, 2, 3. So this is my first point. My first point is in line with negative 2 on the x and in line with negative 3 on the y. The next point is minus 1, minus 1. So I'm moving to the left minus 1 and I'm moving down minus 1. Right? So minus In terms of our x coordinate, is a shift to the left. In terms of our y coordinate, is a shift downwards. Right? This one, we have 0, 1. So we're not going left or right. We're just staying on this line and we're going up 1. So this is the next point here. Then we have 1, 3. So across 1, up 3. Then we have 2, across 2, up 5. Right? Let's get a different color. And we could draw our line connecting all of these points. And we label the line. This is y is equal to, what was it? 2x plus 1. And this is how we complete a table of values and draw a linear equation on a graph. Now pay attention to a few things. My center in the graph, the origin, 0. I label my y-axis here, my x-axis here. Our scale. The scale is telling us how the units are represented on each axis. I say 2 centimeters to represent 1 unit. Every one of these boxes here on my screen is 1 centimeter. So 2 boxes here is 1 unit. 2 boxes here is 1 unit on both axes, on both y and x. You'll notice that every time I skip 2 boxes, I have another unit to represent. Yeah? All right, so let's look at this other example here. We have y is equal to negative x plus 3. And we have this table at the side here. We have values of x between negative 2 and 2 inclusive. So x is going to assume these different values here, right? So I have minus x plus 3. I'm separating the equation into 2 parts. So I have minus x plus 3. And my answer here is going to be the minus x plus 3. So I'm just breaking it up. Now what you're doing here is each one of these values is multiplying by the negative sign here. So minus 2 by a minus will give me a plus 2. Minus 1 by the minus here will give me a plus 1. Because we're replacing this x with these numbers on top. So if I replace x with a 0, I'll get 0. If I replace this x with a 1, I'll get minus 1. If I replace this x with a 2, I'll get minus 2. To all of these numbers, so you work out what different values of x will be. We need to add 3 because y is minus x plus 3. So if we add 3 to all of these numbers, we'll find out the corresponding value of y when 2 is negative 1, negative 0, 1, 2. So we're getting a 5 here, a 4 here, a 3 here, a 2 here, and a 1 here. So these are the coordinates that I will be using to plot onto the graph. These are the coordinates of the points that will be going on the graph to draw that straight line. So let's just copy down those coordinates so you have it close at hand. So I have minus 2, 5. I have minus 1, 4. I have 0, 3. I have 1, 2. And I have 2, 1. First value is my x value. Second value is my y value. Right? We have our y and x axes. So let's look at plotting these points. So we have minus 2. So we come across here minus 2 and we're going up 5. So this is the first point. Second point, we have minus 1, 4. So we come across to the left minus 1 and then we're going up 4. Bam, this is it here. Right, then we have 0 and 3. 1 and 2. And then 2 and 1. And those are my points here. And that's my line of best fit. And then we write our equation y is equal to negative x plus 3. Yeah? Everybody right to that one? All right, so sometimes our equation could look like this, right? So we have 0.5. What we would want to do here, though, is to use values that would make it easy for us to work out. So 0.5 is a half. So what I did is I use all even numbers. So 0.5 and negative 4 here going to give more negative 2. 0.5 or negative 2 give me negative 1. 0.5 or 0 is 0. 0.5 or 2 will give me 1. 0.5 or 4 will give me 2. So you see what I'm doing? I'm basically splitting up the equation into its individual terms and working it out, especially where I have the variables involved, meaning the x, because this here is assuming these values. So I need to multiply by 0.5 by each one of these to get individual values. And then what I will do after that is I'll just subtract 2 from each of them. Right? So this is a lot easier than actually doing it in a more substitution method where you substitute the minus 2, right? Minus this, and then you have to work out all of this to try and figure out what the answer is, right? So you do it in the table here, it's faster. You break it up into individual parts, and then you're going to get corresponding y values one time in the table, so you could select a pair coordinate. So minus 2, remember when you get to this part, you're looking at these two here. Minus 2 give me negative 4. Minus 2 minus 1, sorry, minus 2 give me negative 3. 0 minus 2, pay attention to the ones with the 0, because you're not multiplying in this instance, so you get minus 2. 1 minus 2 give me minus 1, and 2 minus 2 will give me 0. So these are the pairs of my coordinates that I'm going to get here. We have this, minus 4 and minus 4, minus 2 and minus 3, 0 and minus 2, 2 and minus 1, and 4 and 0. I usually circle it, so it would help visually to know, all right, these are the points that are plotting, and I don't make any errors and mix up the numbers with anything else there, because you have a lot of things going on in the table, right? So I identify, I would always take them out and write the points like this, especially on my graph page, or wherever I'm going to draw the graph. So I don't need to be going back and forth. Going back and forth might present a scenario where I might easily mix up things and get wrong. Yeah? When we write all of the coordinates close to where we're going to draw our graph, it's easy for us to just look at it, right? Minus 4, minus 4. So remember, this is our next thing I do too. I'll put the x and the y here. So I know all these on this left-hand side is x values. And to look for my x values, I'm looking on the horizontal axis. So minus 4 is across here. And I'm going down, right? Because minus on the x is to my left. And minus on the y is to go down. So I'm coming down here. Bam. Then after that, I have minus 2 and minus 3. So minus 2 to the left and then 3 down. Then I have 0 and minus 2. So anytime you have a 0, that point going to be on one of the axes. So here my x value is 0. So I'm not moving left nor right. I just remaining on base. But I'm coming down 2. So 1, 2, I come down here. Then the next point is 2 minus 1. So I come in to the right is a positive 2. So we're going 2 times to the right, and then we're coming down negative 1. And then the next one is 4, 0. So I'm going 4 times to the right, but I'm not moving up nor down. I'm staying right here on the line. See that? And this is what our line going to look like. Right? And we just write our equation of the line. This is y is equal to 0 0.5x minus 2. Right? Double check to make sure you have your axis label. So axis label here, axis label here. You have your scale. You always show the origin, which is 0 in the middle here, where the two axes meeting. You clearly identify all your points, you draw a line, and you label a line. And that's a perfect linear equation on our graph. Right, so let's look at this one. So we write in the equation 3x minus 4 like this so that we could work out what 3x is, then subtract 4 from it, and then we write our answer for y underneath here. Right, now remember x actually assuming these values here. So 3 by 0 going to give us 0. 3 by 1 will give us 3. 3 by 2 will give us 6. 3 by 3 will give us 9. 3 by 4 will give us 12. 4 is our constant, is minus 4. So I just taking away 4 from each of these. And when I do that, then I'll work out what? 3x minus 4. So 0 minus 4 will give us minus 4. 3 minus 4 will give me minus 1. 6 minus 4 will give me 2. 9 minus 4 will give me 5. 12 minus 4 will give me 8. These values here now for x and y is what making up our coordinates. Right? So 0 and negative 4 is our pair. 1 and minus 1 is our pair. 2 and 2 is our pair. 3 and 5 is our pair. 4 and 8 is our pair. So like I said before, I like to write these out close to where I draw the graph. So I don't need to be going back and forth. And I don't mix up any of these numbers, right? So I just write them out one time to avoid any confusion. So when I started plot points on my graph, I'm looking right at the side of the graph. And I'll see normal coordinates. Right? I just like to put an x and a y here, so I remember what's my x and y values. And I go and drop these in. So I have 0 and minus 4. So remember your x telling you whether you're shifting to the left or to the right. So if I have 0, I'm not going left nor right. I'm just staying on base. But I have a minus 4 here, so that means I'm going down the y-axis 4. So I'm actually starting from right here. Bam. Then I have 1 and minus 1. So I'm shifting 1 to the right and coming down 1. Then I have 2 and 2. So I have 2 to the right and then 2 up. Then 3 and 5. So 3 across and then 5 up. And then 4 and 8. 4 across and 8 up. Scale anyway. Shift that to the side there. So 4 and 8. Right here. Bam. And let's just make this a little smaller so we could draw a line. There we go. And just remember to write the equation. So it's y is equal to 3x minus 4. And there you have it. Right? Table of values and our equation and our line on the graph. Remember, always include your axes, scale. Make sure your points are clearly labeled on the graph and the equation on the line.